Okay. So here's a normal distribution. And what I had when I was testing this, I had 1,000 runs of it. But let's just look at 100 runs on a normal distribution. And what I've done is I've set it up so that the mean is 0. So maybe just for simplicity, maybe we said the average height was 5'10", and there was something around it. I would be calling 5'10", 0.
Okay.
And then these are the deviations around that. And then, is it on screen there? Yeah. So the max of this was 3, and the minimum was minus 2.8. So tell me some things that you notice, or some other things that you might want to see to help you understand this distribution, because this is a histogram of 1,000 points of data. So what are some things that you notice, or what are some things that you would like to see?
Well, we've got a lot, like the majority of the data seems to be around the average right here, or the mean in the middle.
Okay.
So, yeah. So we have, most of the data is around the middle, few data is further from the middle.
All right. What do you notice?
Well, it seems like we might be able to get like a better approximation because we're only using integer intervals, so maybe if we split it up more, it would look more and more like the actual bell curve.
Okay.
Like that.
So I think the easiest way to split it up more is just to take more data points. I'll switch over to 1,000. What do you expect to happen to the max and min if I use 1,000 data points instead of 100?
The maximum should get larger and the minimum should get smaller.
Okay. So what do you guess it would turn into?
Maybe the maximum's like 3.5, and then the minimum's like -3.
Okay. Yeah. Not too bad of a guess.
All right.
What else do you notice here? Or what else would you like to do to understand this distribution a little bit more?
Well, we could look, I guess, like how much of the data is within one standard deviation.
Okay.
Because I think for a normal distribution, it's 66%.
Yeah, that's probably
Something
roughly
like
right.
that.
2/3 is within a standard deviation.
So maybe
We don't need to get that technical about it. But yeah, we could look at how much was in these first 4 bars or something like that.
Mm-hmm.
Yeah. Okay, good. That'd be a good thing to look at.
We could I don't know if we could overlay like a normal distribution over this.
Yeah, we probably could. That wouldn't be too hard to code up to do. Anything else we would like to do, maybe?
We could run it a
We
couple
could run
more
it a few
times
more.
and just see that, make sure that it stays vaguely in a normal distribution shape.
Oh, that's a good idea. Okay, so here's another 1,000 points.
I mean, it looks different, but it still looks vaguely in the shape of a normal distribution.
All right, what do you notice that changed and what didn't change that much?
Well, this column here got a lot smaller.
Okay.
That's the main thing. I think this one got bigger.
I think it looks like the maximum got a little smaller, but the minimum got larger. I mean,
Okay.
the minimum got smaller too.
All right, and now I'll just show you with 1,000,000 runs. There's 1,000,000. Okay. And what can you say about this?
So it looks pretty normal, I guess. It's
I mean,
these columns are
They
almost
line up.
exactly
Yeah.
the same, but that's probably just because of the scale we have.
Yeah. And what about the max and mins?
They've
They're
increased,
pretty
but
large.
not by a whole lot.
Okay. All right, cool. So now we're going to take a look at another kind of distribution called the Cauchy distribution.
Okay.
Okay.
And we'll see if we can say, hey, yeah, this really looks different than a normal distribution. Okay?
All right.